it won't be a very big session as such. I just wanted to confirm some things with you. Good that everybody did registration on the CN, and some of you have sent the reflections also, and hopefully you have received the assignment posted over there. Did you see that? There is a, in the post we have created one assignment, and what is that? That was your yesterday's assignment, what sir had asked you to do. Today what sir has asked you to do, that again I will post it there, and then also today I will post those his slides also, PDF also. It seems there is some internet connectivity issue. I thought I should take you to the journey of information system. But anyway, even if there is no internet, we can do something on that. Just let me give you a brief idea about what is it and why it is useful, and then actual practice I can show you by using Excel sheet just now, which probably is known to everybody. Everybody knows Excel or not. Let me know what is your computer's background, how much of computing you know. How many of, hello, I am audible for online people? Hello. ऐकू येत आहे ना? For all of you also my voice is okay, good. I hope they also are listening. Now the point is, before taking you to the journey of information system, let me tell you the preamble or background of what is that. It was planned like this course should ultimately lead to interdisciplinary research, where generally the lacking themes are chemistry people know chemistry and computing people know computing, and outside India mostly people know many things together, and therefore they can do simulation experiments also. Even now you can see most of my chemistry students, university chemistry students ask how much of wet lab we are doing, and if there is no wet lab we can't do anything like that, their perception is. But it is very wrong perception. When there is computer you can do many things, and this is really a cost effective solution. You can do many things which are not possibly doable in your wet labs. That type of thing is called as, that technology is called as simulation. Have you heard of this word simulation? No? Yes. How many of you know simulation? What is simulation? Yeah, take microphone in your hand. Where is it? What is simulation? Yeah, little loud so that it will get recorded.
Mimicking the external environment so that we can get used to.
Yeah, mimicking the external environment in computers. That is, then what are the advantages? How many of you do not know anything about simulation? Everybody knows? Yes, you know? If you don't know, you should say I don't know. If you know, you should say no, so that I will come to know how many people do not know. So otherwise, how can I need to know LCM of you? No? Okay, where should I start and take you? All you people know. You know what is simulation? Yes or no? There is nothing shy to feel about. As I told you, I don't know ABC of chemistry. Similar way, there might be possibility you have not seen anything of computer, but nothing is wrong in that. We shall start and work on that. So how many, please tell me how many of you do not know what is simulation? That girl said correct. What is your name? Satya. Nitya. So Nitya said it is mimicking the things in computer. What about you people? You know it. You don't know. Two people? You know it. What about you? You don't know simulation. And here you both, you don't know, you know it. Good. So it seems like 50% of the people know what is simulation and 50% of the people do not know what is simulation. That's a good mix in the class. I really like this because 50% who know, they can develop themselves more to let the others know, so that others also will not feel shy. They can ask the questions when their peers know. When, of course, I am always accessible. You can talk to me as well. So let's take a very simple example. This drug discovery is something which probably is a bit difficult to imagine. You can have some simpler examples like, are they really simpler? I don't know, but still, imagination point of view, they are simpler. Um, when somebody, how many of you know car driving? Oh, great. Everybody knows car driving. I don't know car driving. You don't know? Good. So both of us do not know. Fine, doesn't matter. But then you must have gone through the RTO test. And before that, you have, what did you do? How did you learn car? You joined some class, and then you went there. So what was taught in the class? Yeah, you had simulation class only. So you have undergone the simulation experience actually. The car which was made for you in that class, the driving motor school, motor driving school, was not a real car. It was a real car, but the controls whichever were provided over there, they are provided with you when you are going for a real car on the real road, were not the same. That time, if suppose you put your leg on accelerator, then and again if you go wrong, then also nothing would go wrong, because the next to you the coach was sitting and he also has a set of controls. So when you go wrong, he will employ his controls and accordingly that will go well. Yeah, then the point is, yeah, I was telling you okay, already you all have gone through the simulation experience because your coach, that driving license provider or driving training provider had another set of controls. So when something goes wrong from your side, or if you are not taking control in a right space, right speed, then that fellow will override you. So that set of control was overridden on your set of control. Your things are nullified when that person is using the same control. So speed is increased, or reverse it is taken, the car is taken reverse, or car is going forward, or taking some turn or stop, many functions. So all those functions, there are two sets. One is given to you and another is in his hands. So whatever is in his hand is simulation of whatever is in your hand. You understand what does it mean? What is simulation? And then now what experience you are going through itself is a simulation, because when you are driving a car, you are feeling that yes, you are driving a real car, but it is not true. That's not a real car, it's something simulated car. Now you can imagine what are the advantages and drawbacks of this. Car is pretty simple case per se. One can even afford to go for real car, and accordingly, even if you commit some mistakes, then also doesn't make much difference. Means yeah, it will cost you something, but the cost will not be so much unaffordable. Imagine a case of spacecraft or an aeroplane. You should be given, see, for a simple thing like car which you are driving on roads, you need to learn, you need to take a training for a couple of months, and then you have to go to RTO and pass the test. When you are going for air traffic control system or flight license, then how much training is required? That training is of some 1 year, 2 year or whatever. And okay, one part of that training will be theoretical idea of aerodynamics and everything. But when you are going as a pilot, you should be given experience of being in the air. Not that you can be just told कि हाँ हाँ ऐसे है, अगर हवा का जोत इतनी ज़ोर से आता है तो आपको ऐसे करके फ्लाइट को कंट्रोल करना है. इसका कुछ फ़ायदा नहीं है. When you are directly put in the air, you will not able to manage that, because the whole experience will be different. So therefore you need to be put in that experience only. हवा का जोत कितनी तरह से आ सकता है, how your flight could be getting jerks, what level speed, actual speed what you are looking at the accelerator and all something, and according to the other circumstances, effective speed is different. Many things you have to do that, you have to learn. So all that learning is provided through the simulation model. So in the flight schools, they provide you a simulator or simulated plane, flight aeroplane. So in that, when you are sitting, all those control are there, and behind the screen there will be something which will provide the parameters to this function. So the speed, when you are doing something on your screen according to your control buttons and all, but then you have to simulate the external environment. So now it's storm. So the creating that atmospheric band of which will generate the effect of storm around that aeroplane. It is artificially created because you have to be given the experience for couple of minutes, and then it is to be tested that you are flying properly or you are controlling properly. So suppose rain, how this flight controller will have to take calls in various different situations, rain, fire, very hot, very cold, many other circumstances. So all those these effects are created artificially, and in that you have to show your skills. So that kind of culture is a simulator environment. Even when you go for the RTO test, you remember what is the type of RTO test you take there? One very important test is you have to draw in H shape. Why that H shape? Why not some other shape? Yeah, everyone should know the answer. It has, you should prove that you can take right turns, you can take left turns, and you can go straight and all. Means changing the direction and going slow, going straight. All the things are, and then curve wise also. Arcs are of different radii. That is again a simulation of what? Simulation of what? Your rules. When you are driving on the real roads, what are the things possible? You will drive straight forward, you will go backward, you will have to take left turn, you will have to take right turn. Sometimes road itself is curved, all that. So all whatever, and then there when you go for the testing, then test, you will see that they put the signage. Accordingly, you have to change the speed. So maximum speed limit 40 per kilometer. If you see that, then they will see whether you are doing it properly, isn't it? So that is when you read the signage given on the road, and then accordingly are you able to employ it. So all that culture which is available on the real road experiences, that is simulated in that RTO platform. So the idea of simulator is clear. Now let me see if they have any problem. I have posted mechanism, yeah, okay, that definitely I will read it later. If the internet is available, I will show it everybody just now. Fine. So we are talking about simulators. I think all online people are also with me. They understood what is simulator, or if they priorly know, no problem. Next is, now we have to think of, suppose more than that, the higher costing if experiments are of spacecraft, like our Vikram, who is lost almost, means could not control itself the way we expected. How the people understand that? The astronauts, yes, they don't know. Hello, 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 hello. Desktop sharing is on. Hello. Please respond if you are not able to hear. Okay. So then they will have to undergo lots of simulation. Means we do not know exactly what will be the. So what has happened, sir? हां, but they are saying no, we can't just say की बरोबर आहे सगळं. Hello. Check with that our office terminal whether you can read it there, listen to that there. So for aircraft and all, that is more difficult situation because it's again cost of the experiment is in crores and cost of the experiment. Okay, anyway, I'll repeat it again for them later on. Even I can send some links in simulation, links on simulation. So cost is very high and the time taken for the completion of the work is very high, or many things. So what we were talking was about this thing. When there is a very hard costly systems, then probably there is a point in going for simulation. So simulation helps you not to go to the real environment and understand what are the dynamics of real environment. Understanding the dynamics is important. The static parameters one can analytically compute and understand what will happen next. But dynamic parameters, there is hardly any possibility unless you put them in the circumstances you will understand. What do you do in your wet lab? I don't know about the drug discovery per se, but can somebody of you tell me what is expected in the wet lab of drug discovery so we can take it in the simulation experiment? Means what?
Synthesis.
Means what?
Preparing new compounds.
New compounds. So how do you prepare it?
By applying all these chemical reactions.
By applying chemical reactions, you prepare new compounds. Yes. So by applying reactions. When do you say so, then it means some substances are taking part in that. So how do you know which substances should be considered for participation in one reaction? Not any X and Y can come together and let them do some reaction. We can't go by that way because that's a very risky proposition. There can become an explosion or there can go something wrong, fire, anything, I don't know. But there is a possibility. Then you probably have studied some things and out of your experience or study you know that some X and some Y can come together and some process needs to be applied over there so that so and so is the result expected. That is where you know the entities, isn't it? We are talking about unknown entities. Then what to do? Then what to do?
Trial and error.
Trial and error, yes, and trial and error, I don't know the exact exact cost and all, but when I go for the meetings, the head of the department's meeting is conducted, then chemistry people, huge budget they want to give for that purchase of substances and these things. And generally we have budget for only computer purchase. So then I wonder, every year you consume so much of substance, so much of these substances, and they said yes, it's most of the times it is in trial and error. Say now imagine when our university department has 300 students in their masters or more than that might be, and each individual has to do that experiment, and small amount of substances if they are given to them, each substance is a costly affair. And I heard from them only that every time it is not possible to buy the substances, they are sometimes out of the stock and all. And therefore, I remember when I was doing chemistry in my young age, Then we used to be given some time slots, and teacher would expect us to attend the practicals in that time only, because that experiment was set up in the lab. So everybody will be given the same substance, everybody will be given the same chemical, same reaction. So everybody has to do the same thing on in that slot. So if I miss the practical, then next time I will have to attend the next practical. My missing practical, if I have to take it, then I will have to take a special permission, and if there are so many people like me who have missed at least 3-4, then they will arrange it. It is a very tough thing, means I really felt when I came to computers that is a tough thing. Why? Because in my computer science lab there is no such control. I can ask the students to come anytime, do whatever you want, and do whatever you want. Anytime, anywhere you can sit, not necessarily you should sit in the lab, not necessarily you take my permission. When there is a Wi-Fi and when there is electricity, they have no problem. And they can sit in the class, they can sit in the lab, they can sit somewhere in the garden, anytime, Sunday, Monday, Tuesday, Wednesday, morning, evening, anytime. And I am also available online, so anytime if they have any query, they can ask, and that's how we work. Why I can trust them so much? Because there is no risk. Why a computer lab, chemistry lab cannot be trusted like this? Because lots of implications are involved. So there has to be lab assistant. In computer science, we do not have lab assistant at all. There has to be lab assistant, there has to be junior teacher, there has to be senior teacher. We don't have any such hierarchy because there is no risk. Once the machines are available, till the time they will last. So you can play with them. So this playing with something is very important when you are doing experimentation. When you are doing in the real wet lab, most probably there are limitations. You cannot just extravagantly use the things the way you want. So, and that is one of the constraints in going for exploration. Having said that, I am nowhere denying the importance of wet lab. I know the importance of wet lab, but then the new trend, or I can say nowadays emerging trend, is that instead of going for wet lab, if you are experienced of wet lab, if you know how to do it in the wet lab, just don't go for the wet lab, go for the simulation lab and try it whichever way you want. And then once you are done with, okay, so and so doing this, we can reach to this level, then if you are confident now it has happened like that, it will happen like that, then exactly if it is happening or not, that you have to verify. So then only in the last stage you go for the wet lab, and all other prior stages no need to go for wet lab. Even I can tell you examples of online teaching this physics and chemistry kind of subjects. Mostly initially people were not very comfortable with this idea. No, our students should know what is it and how it should work. Even I remember one of the persons had said ki Young's modulus experience. It has to be that wire gets prolonged, elongated. So elongation has to be measured and then it has to be written and all that. So fine. Where do we stop to you to do that? Even here we are doing it in a better manner. Anytime you want to come, you come. There is simulated experiment of Young's modulus. Yes, Young's modulus is available in your audio visual mode. Then there is a control. You can just keep on adding the weights over there in the hook and the wire. Then automatically, depending upon the, of course, we have to put hard efforts to create such experiments, I assume in the simulated lab, but according to the machine, whatever is the program, the wire gets prolonged, and that elongation you can just there is a scale also, so you can just see there. How do you measure it? By using scale over there. You just see on the screen there is a scale, and using that you mentioned whatever are your readings. So there is no harm in going for me. In fact, there is no less better experience when you go for the simulation labs. In fact, it is a very safe experience, and anytime, any number of times you can repeat it. I can take example of psychological lab. There was one simple experience. First of the experiments in some B.Ed or some class, it was learning curve analysis. So learning curve analysis is something where you are asked to, you are given a different map, means A is called as C, B is called as K, Z is called as B, and B is called as Y, whatever. That map is given to you, and then they give you a sentence, and looking at the map you will have to write the new form of the sentence. Are you with me? You understood the experiment? And then they will keep on giving you first sentence, second sentence, third sentence, and likewise. And then say for example, I give you 10 sentences, and after 10 sentences they will ask you, now go and check how many times you committed mistakes. Chances are there that because you have read B, even if B was mapped to Y, you have written B only. Or there can be anything else also. B is mapped to Y, but you have written X. Some omissions are there, something like that. You write 2 times, whatever. So count the mistakes in each of the sentence, and then they count the number of mistakes occurred. What is the trait? If it is increased, if it is decreased, or what affects you. After a while it is decreased, or whichever way it is. So this experiment, when they do in the what they don't call is a wet lab, it's a practical lab. In a practical lab, how many times you can give this kind of experience to the students? Again, like my chemistry lab, everybody will be given a schedule. The student has to come, sit, the teacher will dictate, and then that they have to count, and then they have to count their mistakes, and then find out what is the trait. So once in a year only this experiment can be conducted. The same thing happens when somebody is not available on the day, they cannot repeat it. More or so, when the students are available, then also not everybody understands the experiment in the first go. They require some repetitions, and then it is again a costlier affair. There are many things where we can see in the science nowadays, the such kind of labs are not very encouraged. Instead, we encourage to go for simulated lab. Here the simulated lab is pretty simple. You can just have the map generated on fly, then take sentences randomly selected, ask you to type it in editor, then machine, even that tedious task of checking how many times you mistake, that is wrong. Sometimes you commit mistake in counting also. So that you don't have to do, machine will do all that. Then what is your trade? Letting the arts faculty people to know how to draw graph and how to interpret graph is a challenge. Instead, machine itself can draw the graph, and machine can tell you what does that graph means. And then this experiment can be repeated any number of times, and that makes sense, because one important characteristics of learning curve everybody can understand is, if you are not in the mood of learning, you will commit more mistakes. If you are very enthusiastic in learning, you will commit less mistakes. And then everybody has a span. Somebody may commit mistakes initial stages, very enthusiastically started, and after a while the interest is lost, and then he will say, oh, stop it. So that is possible. Somebody may not take a speed very fast, very quickly, but once reached, it has that person has a span of attention for longer. So once his understanding is increased and he understood the map becomes by heart, then onward how many times you ask, no problem, I will just give you for longer duration I will sustain. Everybody's curve needs to be checked by experimenting with the person at various different points in time. And no, you do not require that dependency needs to be reduced. Then the reliability will be increased. Whenever you feel you come in the lab, do that experiment. You don't be dependent of somebody as an instructor or some other instrument or something like that. You can have many possibilities, like are you sustainable with the difficult sentences, are you sustainable with the longer sentences, or you want to go, you are performing good only with the small set of sentences, or whatever way. Are you even comfortable if instead of letter mapping with letter, if I give you letter mapping with numbers, or if I give you letter mapping with some pictures, what is your level of comfort in different environments? So all that can be done using simulation experiments. So similar way, I believe that in chemistry simulation labs also, which means I have seen those things already. Simulation labs for chemistry are very important, where somebody has already programmed the machines, and what your job is that you select that will be interface. So you will select what are the substances, what type of process you want to let them undergo in, how much time it should be there, what level of intensity is required, whatever are the parameters you generally sit in the lab and do, the same parameters are given, the control is given to you. You can change the values of the parameters and see the effects. Effects means effect will be also displayed. The effect will be told, okay, this is the effect. So depending upon that effect displayed over there will be a kind of feedback to you, and then depending upon that your brain will start working and you will something will click to you, okay, let me change this in this way and then try again. You need not do everything again. Now what you are done, just some small change. So let the machine take remaining all things as it is. So you just change the value of something and then repeat. The repeat is the repeat click, and then machine will do everything on its own and tell you what is the impact of it and how much time it takes. See, first important thing in the wet lab is you can't just increase or decrease time of the reactions. You have to do the reaction for the stipulated time, and then sometimes my students work overnight and some reactions are generated or experienced using couple of days also. Then that generally I have heard creating culture kind of experiments. So then they are 2 days of culture, 8 days culture, what all they keep on talking. I have not done that kind of thing, but these are the things they do. But in that case, and then suppose climatic conditions change, which you do not have control, even if you say it's a control lab, but then climatic conditions do have some impact on that, or some other thing comes in picture so that culture gets spoiled, or chemicals also may have some other parameters, effect of parameters. All that things will not be a part of your simulated experiments. Your simulated experiments, and then of course you have a possibility of experiencing that also. So there will be a climatic condition, you can add the random change in that and see what happens. And then speed and all also, that's your control. So if you want to say repeat this for 1 day. So for 1 day means what? Machine did not work it out for 1 day. You know at what speed it works, so you can put that as a parameter, speed as a parameter, increase the speed, and then everything will be, again the time is also simulated, and therefore depending upon the computations involved, here the time required to complete any kind of computation is a function of the amount of computation involved there. If the number of computations involved are large, it will take time depending upon the capacity of the machine. If the number of computations are small in there, then it will give you faster results. So one important thing which we wanted to introduce in this class is that when you are going for the rediscovery of something or inventing these chemical entities from the traditional entities, always you cannot take everything in the wet lab. Wet lab needs to be complemented with simulated lab. Okay, one point was this. The second point is how to get prepared for it. So how to get prepared for it means you must have some mechanism to give the data to machine, isn't it? Since somebody has told you what to do, then only you do it. So you have to tell it machine, so machine will do it. So we will not expect you to write the programs that what happens behind the screen, but what we will expect you to develop some input data or data entry sheets of the real data, and let's put that data, and then you only tell me what is that you want to do of this, and then how best by using some simple software we can produce some substantial results. That is one thing which is planned over there. And this experiment, as sir was discussing with me, we will not able to complete it in these days, 10 days, but this can go longer. That's why I said we shall be meeting on LMS. So you can create data and then you can put it there or there, and then we will give you the data analytics of it. So nowadays you must have heard the word data science. Have you heard it? It's a buzzword, data science. So they take large amount of data and analyze it, and then try to find out the answers for many difficult problems. Like what they do in the spacecraft, the same thing. We do not know what is happening on Moon. We do not know what is happening on Saturn, but just what we can do is taking data from available images and all, and then imagining what is happening over there. And then maybe based upon some samples sent by the previous researchers, analyzing them, we can imagine what is happening there, and then based upon that we have given the control and all those parameters to the recent crafts. So experiments can go to any extent first, but the two things are important. We call it as a back end and front end. So and any system if you consider, there are three things. One is that you have to input data, then you have to provide the process model for it, and then you have to provide the interface for it to generate the output. So, input, process and output, these three things are important. And then process is something where domain expert needs to tell computer scientist what is to be done. So, computer scientist will write simulated programs so that machine will behave according to your expectations. And then input is that which the data you will be giving to the machine, which actually you take in your hands and do experiments in your wet lab. Output is something depending upon that data, for the given data, the given processes, what is the outcome possible, that imagination or analytically identified answer. So, simulation lab and information systems, two are the important points, two are the important things when you all learn something regarding this reinventing. The inventing, discovery, all these things nowadays, if you do not know the data science, you will feel handicapped. And learning data science is not very difficult, any even arts faculty people should know, and they can also learn. Not very hard stuff, mathematics is involved over there. And even whatever mathematics is involved over there, you do not have to do it on your own. There are systems, they will do it for you. You just have to know what is there to be applied. So, learning this background is important. So, what we try to do here in this course is that just let us try and find out the idea about it, explore the idea about it, and learn the background information. So, next I do not expect you to start writing programs, because if that comes that easy, then why should we spend decades in learning that. But at the same time I must remind you, if there is no dialogue happening between us, if there is something like you do not understand my language and I do not understand your language, then interdisciplinary research is very difficult. So, to happen that type of interdisciplinary research, we have to have a common platform where we can exchange our ideas. So, you will tell us what do you want, we will tell you what can we do, and then convergence will happen at certain point in time. So, you will tell okay, if not this way also we can go, then I will say okay, this is possible, and I will say but do you want me to do some such thing, then you perhaps have not thought of it, you will say yes, that will help. So, that kind of, but unless we do not know each other, we cannot do it. That is the experience. Sometimes it happens that many people think computer can do anything, and then they just ask us to do the task. They are equally fancy for us and for you. Those are the fantasies in the word of fantasies only. I cannot just tell you, yesterday I was telling my students we should now list out the types of projects we should take up in this semester, and what would you like to do? Then somebody said time machine. Time machine is fantasy for you and fantasy for me. We will not take that time machine experiment. But then what else you would like to know? Okay, you can tell me something like I do not know this mathematics, but I want to learn it. That can be taken as an experiment. Or like this, if you do not want, and like say for example chemicals, handling chemicals is not a very easy thing. It has professional hazards also. Handling machine is safer relatively. 100% nothing can be safe, but sitting across machines for hours does not make me feel tired, or that does not have more impact like what chemicals may have. That is pretty safer environment, and that is also one more important thing. Therefore, I can spend more time on the machine, I can imagine, I can think, I can let machine stop, I can sit at anywhere, anytime, all that. So, the people are more towards this kind of technology. If you do not understand our limitations, and if you expect everything can be done in machine, then nothing can happen. And if you cannot understand my language, yes, what I want, and therefore, if you cannot provide us input, then I am helpless, I can't do anything, because unless you tell me what do you want, I can't write a program. So, I means any computer scientist. So, there is a need to develop a dialogue between these two disciplines. That is why we thought that we should come together, and every day we should spend some time together for this. So, today it was just an introduction talk. Tomorrow onwards probably we will start working on it. How many of you have worked on computers? Everybody. So what type of work you have done? PowerPoint, yes. You? Programming you know? C programming? Little programming you know? Acha. Everybody knows some beginning of the beginners level programming. How comfortable you are with that? Much is okay. In some, say for example, Hello World program. Have you done it later once that paper was over? So it means you have forgotten it. What was there? Just now you remember. Yeah, there was something, and I have passed the program. Okay, Excel. Everybody has done something in. Good. So what did you do in Excel? सैलरी कैलकुलेशन. केमिस्ट्री के लिए कुछ किया है नहीं एक्सेल में? डेटा एनालिसिस, डेटा शीट क्रिएट किया. किस लिए? या हैव यू टेकन ए चार्ट ग्राफ एंड ओके डेटा विजुअलाइजेशन यू हैव डन that means how big was your data? How big was your data? How many entries were there? 15, 20. Okay. Anybody else has any other experience? Nobody has worked on this? Graph chart, everybody worked, na? So how big was your data? Same. 50, 20 records. Do you think that only 50, 20 record is enough for you? For a maths person like me, 50, 20 के लिए machine किस लिए चाहिए? I can just plot it like tick, 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 tick. And in my days, of course, when I did chemistry and all, then obviously we did not have computers. Computer I touched when I went to master's degree. Graduation में तो नहीं था, graduation के लिए maths ही था. But that time also we have created journals. They were not using machines. Lots of graph means for electronics we had Zener diode, and also some readings will be in micro and some readings will be in mega, and sometimes negative, sometimes the breakdown happens, so sudden drop. So all that we have to show on graph. So we used to calculate and draw it on paper. So for small number of records, really we don't want machine to go for. But yes, machine will give you fanciful graphs very quickly. For a person it takes time to draw all that and show you. But in the real sense, if you want to exploit the advantage of machine, probably I will say you should take large data sets. One more important idea which I would like to introduce to you is that something called as randomization. Have you heard this word? What is that? No? Good. If you don't know, nothing is wrong in that. It's okay. What do you know about randomization? Everybody has done randomization. I am sure about it. You know lottery? Lottery everybody knows? What is that? Based upon? Lottery. So what is that lottery? Based upon probability, okay. Let's not go to that extent just now. That's a pretty big jump you took. Yeah, there will be lots of numbers, and one of them is lucky draw, right? So in that lots of numbers, there is nothing actually when they are put together in a basket. All of them are similar. Means there is nothing like somebody is fairer than the others, or somebody has less properties than the others, or price wise one has higher price than the others. ऐसे कुछ नहीं है. All the numbers or all the chits put together in the basket, they are of the same value. Then what happens in lucky draw? Somebody goes and picks up one, blind picking up. And that means everybody was of the same value till that point in time. But once something is picked up, then the value of that is suddenly increased, and remaining all of now 0 almost, isn't it? Since if I say one lucky draw, then only one chit which is picked up takes all the value and the whole value, and the remaining all are 0. If I say 2 lucky draws, then first and second will take the values, remaining will not have the values. But prior to that instance, you do not know what are they. Which of the two chits will be picked up is not known to anybody, and that is where it is randomly picked up. Okay. Say for another example, everybody knows tossing the coin, head or tail. Can you tell before tossing it? If I give you opportunity to do it 100 times, I give you a coin and say, okay, do 100 times, and you have recorded head, tail, head, whatever it comes. And then now again I give you that and ask you before tossing, tell me whether it will be tail or head. Will you able to tell me? Yes or no? No, you will not able to tell. If you have by some means, if you could tell it, then probably it's not a random experiment. In the random experiment, the important thing is that only how many times you do it, you cannot predict what is the next instance. Why do we want all these things? Randomization is a very important importance in all science experiments. I can give you example. I was telling you that we need to simulate the dynamic circumstances. So suddenly a storm happens. If I say suddenly a storm takes place, how do I simulate it? So while you are flying, some event should be there where the effect of storm will be created. So that some event should not be known to you. It shouldn't be known to me as well, because even if I am a controller, if I know it, there is a chance that I will give a hint. Then there is no point in training you. So suddenly means I will say, okay, this person is going to fly this simulated flight for 10 minutes, any random point in time create this situation. So that random point may be in the beginning, it may come in the end, it may come in the middle, anywhere. So this is a small example, but everywhere you can see there is a requirement of a randomization. If you don't know how to start with the experiments, and that means you don't have knowledge, but you just guess, yes, doing this may lead to something interesting. What can you do? Then how much quantity you should take? What type of, how much, suppose it is heating, how much time it should be heated? What temperature should I keep? All that, if you don't know anything, then you can start with the random experiment. So you just take something, and there can be some time duration for heating, some temperature, everything is sum now. I don't know what are those sum value. And then something will happen, but then looking at that something, you as a brilliant person will come to imagine, you as a brilliant person can able to imagine, yes, this has happened. So why it will be? Say for example, everybody starts cooking in the young age. Imagine those young days when I did not know cooking. Suppose I tried to go for making rice, simple recipe, and my mother had not told me how to do rice. So what can I do? Probably I know rice means I have to take rice grains, then I know some water needs to be poured into that, I know that is to be boiled. But then I was never keen in knowing what my mother does, how much rice grains and how much water and what time, what amount of time and what level intensity the flame should be. Therefore, my first experiment will be random thing. I will take some small entity of rice, or maybe big, I don't know, that depending upon that the cost will be there. Then I will pour some water, I'll put the burner on for a while and see something has happened. That will be something like rice, but that won't be a really good quality rice. But looking at it, testing it, I'll come to know it has not properly boiled. So it means then my brain gives me feedback, oh, pour some more water. अभी तो वाटर ज़्यादा हो गया, आप क्या करें? हाँ ठीक है और थोड़ा बॉईल करो, लगा दो स्टोव पे. So that way I can do trial and error, and then finally some level eatable quality rice can be produced, and tomorrow I will do better quality rice. So such things happen. So my point here to tell was We can do simulation of the things for learning many things at by trial and error by using various different sets of parameters. The secondly, we need to know the encoding scheme and processing and all the outputs. The thirdly, we need to learn how to use feedback and how to start the experiments. So randomization is useful for that. So 3 terms we learned today. One is simulation, another is information system, and the third is randomization. So assignment for you is, now these 3 things you will Google, find out what are they, and then take an experiment of your own choice, your own liking, and tell us how these 3 things will be useful for yourself to take it ahead. Now you, henceforth you do not consider yourself as a student, you are now researcher. So what all comes to your mind, you must be given opportunity to research, otherwise knowledge building will be a tough task. And don't find it difficult, don't feel that it is a tough task and it is costing and nothing like that. Just try, that's why I said when you are doing it in machine, it does not cost you more. Nowadays systems are available at cheaper rates, and therefore the cost of simulation experiments is reducing, and and there are so much sophistication techniques are available, and therefore you can try variety of things there. Is that okay? Everybody understood the 3 things, introduction to the 3 things. So now try it and post it. I will post that, the title, but in response to that, please post on, please keep posted these things. Thank you.